2018 Section A MTW. Question 1. Tool shown here is sliding bevel used to mark or check lines and angles. Plywood is the material that's shown, the manufacturer board. One advantage: strong, stable, inexpensive, comes in large sheets. It's environmentally friendly, economical use of timber. The diagram shows a deep-throated fret saw. It says identify one advantage of using a saw instead of a coping saw. So you're comparing the two. So coping saw is obviously not as deep, so you get greater access or greater reach. And identify the force acting on the blade. So the blade is being pulled out, so it's put in tension. The name of the power tool shown here is a biscuit jointer. These are the biscuits. It's used for joining wood, specific use, joining wood, cutting the slots for biscuits. Name the method of timber conversion shown. It's tangential sawing, and then on the block it says sketching on all three faces what the grain would look like when it's converted, so it gives that kind of flame feature. Then the tool shown is a hot glue gun. Advantages of using a hot glue gun: easy to use, sets quick. Disadvantages are that it's a weak bond, it's only suitable for light work. CAD is often used by students. What's the CAD letters stand for? Computer Aided Design. Give one advantage of using CAD instead of a traditional drawing board: it's fast, it's accurate, excuse me, it's easy to adjust and change, whereas the pencil drawing would take quite a bit of work if you're changing something else. You might even have to start again. So question 8, why is it necessary to season wood before using in the woodwork project? Well, it's going to be lighter, it's going to be stronger, it's going to be easier to work. It's also going to be resistant to attack by fungus. What do the letters EMC stand for? Equilibrium moisture content. Has to show or name the different wood, different trees from the leaves, and you're given the list: oak, yew, maple, alder, ash. Then there's shown a machine here. Name the machine. It's a belt sander or a bench sander, or some may call it a disc sander. Two work areas, A and B. So A is the flat piece up here, so sanding flat pieces and concave curves because it's curved out in the end. And then for part B, it's a disc, which you use for end grain or for convex curves. The diagram on the left shows the cross section of a tree with a shake defect. On the other two diagrams it says show a cup shake. Now the cup shake follows the annual rings, so anywhere that you draw that's fine. This one follows the heart shake, follows the medullary raise, but it also goes through the centre. Then the recalculation one. So we're showing two gears. This one's rotating this way, so this one's obviously rotating that way. So that's the first part of the question: which way, direction will the gear go? And then we're asked to calculate let's see, the small gear, it's got 10 teeth and it rotates at 80 RPM. If the large one has 50 teeth, it says calculate the rotational speed of the large gear. So basically you're taking the number of teeth multiplied by the revs per minute, which gets 800, then divided by the number of teeth in the big gear, gives you 16. Diagram shows wooden flooring boards which have been affected by dry rot. Three conditions necessary: moisture, food source, warmth, spores, if they've been transported around the place. And then we're given the pillar drill, and we're asked the safety precautions that may be observed or should be observed when using a pillar drill in the woodwork room. Wear PPE, wear goggles, wear dust mask, follow standard operating procedures. So there's a way of working it. Don't only use it if you've been instructed in using it. Secure the workpiece, lower the safety guard, tie up hair, remove jewellery, that sort of thing. So right, we've a right bit of a sketch here to do in the marking out of the haunch, mortise and tenon. So the first thing I'm going to do in this here, and I'm going to do it all freehand, you can use set squares if you like. I'm going to put on end waste because all your pieces, when you're marking them out, you'll have end waste on them. I'm going to pick somewhere about the middle. I'm going to pick two lines to show that that's the piece now divided up. I've got to divide it into two pieces. Then I'm going to make it kind of something that looks reasonably like a square section on the end there, and I'm going to come up to the end of the other piece and do the same, make what looks like a square. Fairly narrow to try and do this here. I'm going to put the tenon on this side, and then I'm going to allow for the haunch, which is on the top of it here, and take it down to about 2/3 of the way, and then just draw that, and then that's challenging enough, especially considering the size. It can make my haunch a wee bit smaller. And then on this side, this would come through, because that's coming round to meet the other side. Yeah, this I've drawn it as if it would be the face side, the edges down here, so the two of them would have to come around and meet, and this will go through the middle. Probably could have drawn it another way, but you're going to lose out something on this here, I suppose. I could have drawn the haunch the other side, but anyway, I'll go over this here just in pen to make it a wee bit stronger look. You don't have to draw anything in pen. It's not necessary, it's only the marking out of this piece. Once you'd have done in pencil, you could go back then and put in your now, technically, I suppose I would have probably been better to try and get a wee bit more information on it, but anyway, if you drew that there, it's how you get your marks. And you only need to put in the waste that's been cut out. I'll use a pencil to put in the end grain. Now, just based on the scale, it's a challenging enough one to do that there, to be honest. Get rid of that there, and that's my haunched mortise and tenon. 16 is chlorophyll, and name the different, they're the 5 woodworking tools: block plane, smoothing plane, bradawl, nail punch, carving gouge. 18 is the ferrous and non-ferrous metals. Copper is non-ferrous, cast iron is ferrous, non-ferrous, and mild steel is ferrous. Right, another bit of sketching, bit of a challenge in this one. Now, if you want to use set squares, by all means, go ahead and use set squares. It probably will get you slightly more defined or definite lines on this here, but a good bit of this is already drawn. I don't think it goes all the way there, it'll probably go down for you. So I've done that freehand, not necessary to do it freehand, you can actually give it a shot. Complete the sketch this joint, colour and shade the completed sketch. Might as well put in all the lines, I suppose. And if you had a softer pencil, I suppose you could give it a shot of shading it in. I wouldn't be going to town on this altogether. Just a wee bit of shading. My pencil isn't exactly suited to shading here. I suppose I should have put in this. Don't overkill it on the shading, it could take away from it then, so that's that. And the last one then, the image on the right hand side shows a fruit and veg thing. For holding fruit and veg, all the joints, all the pieces are jointed together using brass screws and screw cups as shown there. Material is 12mm thick. This is complete the cutting list shown below, and we'll start off with, these are highlighted in red, or wee finger pointing to each of the things so that you're looking for. So you're looking initially for the width of the basket here, so it's 100. Then you're looking for the horizontal rails, these guys going across here, which is 350. Then you're looking for the uprights. Now the uprights are these guys here, and that takes a wee bit of calculating here. So if we start from this side here, you've got 112, but here's the but, that there doesn't go the whole way to the bottom. So but we'll put it in anyway, 112, 55, 100 and 70, and then the radius of this here at the top is 20, so it goes up another 20. Add them together is 357, but then you have to allow for the thickness at the bottom, which isn't actually in that there, so the 12 is taken off it, gives you 345. The brass screws, what length are they? They have to go through a piece that's 12, and they're going into 12, so that's 24, so they can't be bigger than 24, so you'd be 20 or 22 would be fine there. And the last one there, the distance here, 105, was achieved by getting 250 minus the 40, and then because it's even both sides, divided by 2 gives you 105. And that's the 2018.